Hello, today we are going to talk about image stacking for the moon. Whether you are photographing the moon with your smartphone at the eyepiece of your telescope, or using your everyday camera with a telephoto lens, or your telescope with a planetary camera, you will benefit from image stacking. There is no need to buy extra gear for image stacking. It just requires a bit more of time because you will need to collect a sequence of images, and those images can be still images, so you can shoot in RAW a sequence of RAW files, or they can be video frames that are extracted from a video clip you shot with your smartphone or with your planetary camera or even with your DSLR. The idea behind image stacking is that we are going to layer all the images on top of each other, and then we are going to combine them to produce a final image that has lower noise and increased detail. So that's the magic of image stacking. You do not need extra gear to do that, and it's quite easy to do. The concept is similar to that of taking cards and pile them up to form a card deck. Instead of having cards, we have images, but we are going to pile them up to create this stack. Now, differently from forming a deck of cards, then we need to find a way to grade those images in terms of their quality, and then to align those images to the reference frame in the stack, and then to combine those images. So you may think that this requires a lot of work. Maybe you are thinking about digging somewhere in the menu of Photoshop and having to face a lengthy and difficult process. This is nothing. This is nothing like that. You can stack images in Photoshop, but I would not recommend it. Instead, there are plenty of software that are specialized on stacking images, and there are many of those software that are free. Unfortunately, for Mac user like myself, most of the free software for astrophotography is for Windows, so we have to find a way to use those software on our Mac computer. In this video, I want to focus on the classic combo that is used in order to stack moon images, and that is going to Windows and use three free software. The first one will be Planetary Image PreProcessor. It's also called PIPP. This software is used to prepare and preprocess your image sequence. And then we have Autostakkert 3, that is the actual software that will take care of doing the stacking. And then we have finally Registax. Now, Registax was a stacking software in around 2012, 2011, but since then is abandonware. But it still has a great feature that is wavelet sharpening, and this is the easiest way to use this kind of sharpening for your images in Windows. So the idea is that you move from PIPP to Autostakkert, and then you finish off your stacked image in Registax by sharpening it with wavelet sharpening. Now, in Mac, what I have to do is to use a virtual machine. So a Windows virtual machine is pretty much the easiest way to bring Windows software on a Mac. And of course, the drawback is that you don't need to be in a hurry. It will take some time, but you will arrive at the end of the process. So let's see what we have in my virtual machine. Here we have PIPP. This is Planetary Image PreProcessor. So let's fire this up. First thing we are asked is to add the images. So that's what we'll do. I have already here my directory with 80 raw files, and this has been taken with my Olympus EPL6 and Celestron C5. So I have my 80 raw file, and I can import them in PIPP. And what you see is that now we have to deal with the choice. The program suggests to use join mode, and that is what we are going to use because we don't want to pre-process those images independently. We want to create a movie out of those images, because the movie will be what Autostakkert can take. So you can also see that a new Windows appears on the screen, and that is the output frame, and this is where we can see our moon, so the data that we have from the raw. The next thing we are going to do is to move to process option, and here we have a series of options we can use in order to improve the quality of our images. For instance, this moon looks quite dull. We can select stretch histogram white point to 75%. And here we can click on test options. So this setting we have selected will be applied to our images, and here we have a preview. So you see that the moon brightened up. This is quite a common use of this option. So we want to brighten the image, we can stretch the histogram. Then PIPP has another great feature, that is that of detecting the object that we have photographed in the frame, and we can do a number of operations. So this is particularly useful if you are photographing planets. In this case, with the moon, we can still do something. So for doing the object detection, we go to frame stabilization mode and we choose object planetary. And then we click enable detection, object detection. Now we can click on test the detect threshold, and whatever is detected to be as a planet or as a moon will become red. You see here that all the moon has been detected. Then we can center the object that has been detected in the frame. For the moon, we can also choose the phase. In my case, the shadow part of the moon is in the top right hand side, and so I select that. I will not enable cropping, but if you are doing planetary imaging and you have the planets very small in the frame, you don't care about much about the frame, so you can easily crop down, and that will help to reduce the size of the files you have to work with. So in this case, I will not enable cropping, but we can still test the options and check the moon if we'll change position. So it's now processing, and yes, the moon has moved at the center of the frame. The last thing we want to do is to go to the output option. Now, there is one thing that we could do in PIPP, and is grading our imaging in terms of their quality, but I prefer to do that in Autostakkert, so I will not do that in PIPP. Instead, I will go to the output options, and I will choose a format for the video, for the output video, in order to be then processed with Autostakkert. Now you can see here that we have different formats for video. We have AVI, we have SER, now SER. Now AVI, you can see in the description that is 8-bit only. So we shot raw images, and we don't want to lose the flexibility of raw images. So we select the SIR format that is also 16-bit. So if we give images that are 16-bit or more, then the output will be 16-bit. So we choose that, and we are pretty good to go. We move to do processing, and we click on start processing. Now PIPP will run through the image, we convert them in this video format, and then we will be able to import the video in Autostakkert. It will take about 5 minutes or so, so I will come back at the end of the process. Okay, now PIPP has finished to create our movie, so we can quit the program and go to Autostakkert. Now Autostakkert is a software that is free, and you just need to download, and does not require to be installed. Just uncompress the zip file, and then you are ready to go. So let's fire this up. You see that the interface now is in two parts. We have a main window and we have the frame view. The first thing we need to do is to open our video, and this is found in the same directory where you had the original data. So if we are going to find our place, that would be, you see that A new folder has been created named PIPP with the date and other information. And then we have here the SIR movie. You may note that this movie is 7.5 gigabyte in size, and this is where planetary astrophotography gets difficult. You usually have to deal with very large files, and so you need quite a lot of space on your computer and also some computer power in order to process the images. So let's open this video, and the moon will appear in the frame view. Now you see that everything is black simply because the zoom is set to 100%. If we drop it to about 30-20%, we are able to see the entire lunar disk. Now, the next thing we have to do is to choose between surface and planet image stabilization. Now, because we have the full lunar disk, you may be tempted to use planet as image stabilization, but in reality, with the moon, because the surface is so full of details and is so large, it's better to use surface. So we do that. It's already in surface here, and you see that on the moon we have a green box. This is the image stabilization anchor. I usually leave it where it is, but you can move it and set it in our point with the control click. The quality estimator is the engine that grade your images in terms of quality. Now we have a value for the noise robustness of the algorithm. So this value, higher it is, the more the algorithm focus on the largest details, and so it tends to neglect the small details in the image, and hence it tries to neglect the noise. If you have very clean image, you can reduce this value to 4, 3, 5 is pretty much the standard way, so I will leave it like that. And then here we have finally the analyze, and this is what we are going to do. So the software is now going to read through the image sequence, and it will grade all the images by quality, and it will find the best quality image is what will be the reference frame for aligning all the rest of the stack. So this doesn't take much, these steps. You see here in the middle part of the main window, we have all the different steps the program is going through, and we have also a progress bar so you can keep track of where you are in your editing process. Now, the grading is almost finished and done. Now, in the main windows, a new piece of information appeared, that is the quality graph. Once we have graded all the images, we can then display their quality in a plot. The gray line is the quality of the frame as they are in the movie, so they have not been ordered in terms of quality. That will be the job of the green line. So the green line is the quality of the frames that have been ordered by their qualities. So this allows us to see, for instance, that if we stack the 25% of image, we will have the worst quality of that we consider will be something close to maybe 70%. If we allow to stack the best 50% images in the stack, then the worst quality we have is something a bit above 50%. Now this 100%, 70%, 50%, 0%, they are of course referred to the quality of the best image. So it doesn't mean that because you stay close to 100% you will get a very nice image. What the program is telling you is that if you stack images that are close to 100%, then you will get images that are in quality similar to the best image that has been found in the stack. If this best image is ruined by poor seeing, then there is nothing you can do it. So this percentage is relative to the image quality of the best image the program found in the stack. So You can then work to stack options and ask that you want to have a TIFF file at the end of the work. And here we have, you can select the number of frame you want to stack or the percentage of stacks. And you can create 4 different stacks using different threshold for the quality. So for instance, in this case, I have selected that I want a stack with the best 25% of the frame, a stack with the best 50% of the frame, and another stack of the best 15% of the frame, and that will give me the worst quality, something a little bit more than 75%. Under those boxes, we have other controls we can tick to sharpen the final image, and we can also tune the amount of sharpening by choosing the amount of blending of the original raw in the stack. So in this case, I have blend raw in for 65%. That is equivalent to have your raw image in Photoshop on a layer, and then the sharp image on the top layer, and then select the opacity of the top layer to 35. So in this way you can tune how imposing the sharpening will be. Then you can align the RGB channels. You can of course save in folder, and there is also an advanced setting that is the possibility to drizzle the data in your stack to create a super resolution image. Now you can see that the button to stack the image is gray. We cannot stack yet. That's because we didn't define an alignment point. One difference between the stacking for planetary imaging, lunar imaging, and deep sky imaging is that in deep sky you have stars, and the algorithm uses those stars in order to align the different frame. In the moon, in the case of the moon and the planet, we use surface features to define alignment point, a grid of alignment points. So here we do that in what was the frame view. You see the left sidebar. We can draw the alignment point manually, but actually for the moon it's much easier to ask Autostakkert to place the alignment point. We can do that automatically. The only caveat is that you need to choose wisely the size of the alignment point. You do not want to have 1,000,000 of points. You don't want to have too little of points. So for the full lunar disk, I would usually stay around 100-150 alignment points. You can choose the size, which determines the amount of points you will have. You have 4 different settings: 24, 48, 104, and 200. But then you can manually arrive to 400. 400 is the maximum size of alignment point. And so for the lunar disk, I use usually 400, and then we can ask Autostakkert to place the grid. You will see in shortly that one point will appear and the other will follow soon after, and until all the grid will cover the entire moon. Okay, so now the grid is formed. You can see here the grid of points, and now the stack button became available. So if we do that for 3 stacks, then we will have 3 different directory, and the data will be ordered in these different directories. So we will have 3 stacks. Now for the purpose of this video, we can just go with single stack, 25, best 25%, and we click stack. So you see that the software is going through a series of steps. Again, we have the progress bar that to tell us where we are in that particular step. So I reckon will be another 5 minutes or so in order for the program to stack the best 25% of these 80 raw files. And done. So Autostakkert has finished his job, and before quitting the program, because maybe we want to check what is the result, so we go back to Mac, and I go where the data were. So it will be the stacked image will be where was the original video, And you see that we have a new folder here that is called Autostakkert percentage 25. So this is the stack with the best 25% of the images. And inside we find an AS3 file, that is where all the parameters we use for the stacking are stored. And then we have two versions of the stacked image. We have the first version, that is a TIFF version, and I will open in Photoshop so we can appreciate the difference. So this is the output of the stack without any sharpening. And so this is it. And then we can drag in the sharpened version. Remember that this was quite a mild sharpening, but now if we go to pixel PIPP the image, here we can see the effect of the little sharpening that we asked, and that is the stack without sharpening. So with sharpening, without sharpening, you see that it makes quite a difference. So if you are happy with the kind of sharpening you can get with Autostakkert, you do not need to move to Registax. But if you want, you can move to Registax, and then you will have to work with this wavelet sharpening. So we can quit Autostakkert, we can fire up Registax. As I said, this is now abandonware, so don't expect huge performances. There may be some bugs, so I suspect that the more Windows evaluates, the more incompatibility we may find. So anyway, this is the interface for Registax. Let's select our image. So we go where the stacked image is. There you go. And we can take the image that it was not sharpened. Now, if you want to stretch the intensity of the level, you can do it, or you can leave it like that. It will brighten up the image a little bit. So depending on the size of your TIFF file, it may take a few seconds to open and display the image. Okay, so the image has been loaded, and you see here we are already in the wavelet menu, and we have different options here. Basically, the wavelet sharpening works in layer of frequencies, and the layer 1 is the one that targets the smallest detail in the image. The layer 6 is the one that targets the large features. So if you have a lot of noise, you may not want to sharpen too much with the first layer, because then you will also detect and sharpen the noise. But just to have an idea of how it looks like when you sharpen the image, well, we can drag the cursor up to 75% or so, and you should note here that you have a center square where the image looks more noisy, a bit more sharpened. We can pump it up also layer 2 to 100%. Now you really see that there is something going on at the center part of the image. Now this is going completely overboard. Nobody will ever sharpen the moon in this way. So what you want to do is to find a sweet spot between the sharpening and the noise you will introduce. Now mind that for every layer you can select the noise setting and your sharpening aggressivity, let's say. So I tend to do something like so, a bit mild. I try to get a bit of sharpening. I don't want to exceed and to go overboard. Do something like so, maybe even less, and then I can further sharpen in Photoshop if I need. So if I want to see the effect on the full moon, then I will ask to show the full image, and then I will do all. And now, instead to have the little preview that was at the center of the image, you see here we have at the bottom left of the interface, we have a progress bar that will tell us where we are in the sharpening, and bit by bit the moon will be sharpened. And you can see that now the top part is much sharper than the bottom one. Okay, we are almost at the end. And now the sharpening is finished, and we can save our image in TIFF file. We change the name in Registax and we save it. And now we can go back to macOS. We found our image there, and then we can import it in Photoshop to see the difference. The moon has sharpened with wavelet. We can pixel PIPP it, and this is the moon that we had sharpened in Registax. Now, aside the shifting of the image, you may see that the one with the wavelet is a bit more sharpened, but is also noisy. So that's because I didn't spend time to tweak all this setting to have a nice wavelet sharpening. Okay, this is pretty much the end of the process. We have both a stacked image without any sharpening. We have different version of sharpening to choose from. For instance, I like more, in my case, the little sharpening that has been applied with Autostakkert, so I can keep that. And look, the nice thing to have two separated images is that we can reduce the opacity of the layer, and so we are going to further refine the amount of sharpening and noise we are introducing in the image. So I reckon something like this 66% is something that I would agree with. And then from there on, you can create a timestamp for your moon. So, and then you can go, if you like Lightroom, you can go to Lightroom, or you can go in Adobe Camera Raw, and then you do your classical editing. You can increase the brightness of the moon, turn down a bit the highlights, increase the whites, and then you can go sharpen even more with this texture. You see, if I go completely to one side, I have a very contrasted and sharp and crisp image, although will be noisy. And if I go to the other extreme, I have something that is extremely soft. So you can play with this texture, with the clarity. You can play with the haze, so how contrasted the moon will looks like. You can select your white balance, maybe see if there is some colors. Mineral moons are perfect for image stacking, because the stacking will improve the weak signal that you have in every image about the colors, the true colors of the moon. So if you want to do mineral moons where you show the true color of the moon, then you have to stack your images. And so you do this kind of editing. You will have the stacked image that is more flexible than the single raw file, and you will have at the end of the day a better result. So this is pretty much what I wanted to say. We saw how we can stack the image for the moon. We show how flexible the stacked image can be when we start editing. There is a lot of details and color you can pull out with the edited, much more than those that are in a single raw file. And we saw how to do that in Windows. So in the next video, we will see how to do that on macOS. And for the time being, I thank you for watching and see you next time.